Hello everyone and welcome to another video tutorial. Today we're gonna talk all about generics in TypeScript and how they help you create reusable code. Make sure to watch this video until the end because at the end I will show you a real-life implementation of generics in React.js to manage state and types hooks and all of that. So let's get started. Welcome back my friends, I'm Mark Maxey and in this channel I help you create web applications from code to production. If this sounds interesting for you, consider subscribing to my channel to get notified about more videos like this and to support my channel and for the YouTube algorithm. So let's talk about generics now. Generics in TypeScript are types, just like numbers, strings, booleans, whatever. They are types, but they are special in a way that they can be passed as arguments to functions and classes to customize their functionality. Now, let's talk about JavaScript now. If I have two functions like print hello and print hi, and these functions simply print hello and hi respectively. Now, if I want to make these functions more customizable, I simply can write a function called print string. Okay, and pass it an argument. Okay, and then print this argument. Okay, and now I can invoke the function and pass it an argument like hello or hi or maybe a number like 2, and there is no problem in that. And now if I want to convert this to TypeScript, I simply add an annotation of string to this argument. But now TypeScript is complaining that this function can accept only strings and cannot accept a number. To fix this problem, I have two solutions. The first solution is to remove string and add any. The keyword any, in TypeScript is a bad keyword. Why is that? Because it basically makes your code JavaScript. There is no need, it doesn't make sense that you are using TypeScript and use any at the same time because you are basically writing JavaScript when you are using any. So you can use anything here, even bad code, you can use it, there is no problem. So that's the first reason why any is bad. The second reason is if I hover over these functions, you can see that TypeScript cannot infer the type of the argument I'm passing. For example, I pass a number here, but still TypeScript cannot know that this argument I'm passing is a number. And same here, it says an any and not a string. So I need a way to tell TypeScript that I'm passing anything. I don't know what I'm passing, so I'm passing anything. But at the same time, I want you to infer the kind of the type of value I'm passing to this function. So in this case, instead of passing any, okay, I want to convert back to string. Instead of passing any as a type to the argument, I pass a generic as a type. This generic called generic type. Okay, and use the generic type here. So you can see that the generic type is a type that can be passed as an argument to this function. So when I invoke the function, I have to pass a generic type. What is a generic type? In this case, it's a string. And in this case, it's also a string. And in the last case, it's a number. It's a number. So when I say that this function accepts an argument and a value argument as 2 and the type argument as a generic called number, in this case, TypeScript can infer the type of argument I'm passing to the function as a number. So that's the difference between any and generic. So to make things more clear, I want to go to this is my blog post. By the way, this blog post is not published yet, but it will be published as soon as this video is released on YouTube. So if you are watching this video, it means that the blog post is published as well. So make sure to check the description box in order to get a link to this blog post to see my post about generics. I want to show you this diagram. Here in this diagram, the keyword any is a very general word that it basically includes anything, functions, numbers, booleans, strings, anything. But generics, also it's a general word, but it's more specific than any. So that's the difference between any and generics. The second difference is when we are using the keyword any, as we have seen now, TypeScript cannot infer the type of arguments we are passing to the functions. But when we are using generics, like in this case, TypeScript can infer the type of argument I'm passing to the function, like this. It knows that it is a string, and here it knows it is a number, although it's a generic. And by the way, we don't write generic type. We write something like T, and same here, we write T. Okay, there is no special word about T. We can write anything, but in code bases you can see T or U or something like that, or K probably. So that's the point of generics. They are types, and they can be passed as arguments to functions to customize their typing system. Let's see an example of generics in classes. If I have a class called, for example, user, okay, and now let's see an example of using generics with classes, because generics are not specific to functions. They can also be used with classes. So if I have a class called array of numbers, and I want to define a constructor that accepts a collection as a string, as a number array. And then I want to define a method called getValue and pass it an index of number. And then I want to return collection index. Okay, the value of the index. Now, if I want to instantiate this class, I can write const num collection equals new array of numbers and pass an argument of array of numbers, like this. And if I call num collection dot, you can see I get value, for example 0, and I will get back 1, because that is the first index. So if I want to write another class for array of strings instead of numbers, okay, I can do that. And now I can, here instead of num, I want to call it str and array of strings and pass it an array of strings like this. Okay, it works fine, but you can see that this solution is very bad, because I need to define a new class every time I want to change the type of the collection. So it doesn't make sense to continue writing code like that. Instead, I can create a general array called array of anything. And since it's an array of anything, we discussed earlier, we can pass any here, but we don't want to pass any. We want to use a generic. So to pass a generic to this class, I want to pass a generic type as t and use this t as here. And now when I want to instantiate this, okay, when I want to instantiate this class, I want to pass a t. I want to pass the t generic. In this case, it's a number. So when I pass a number, whenever there is t inside this class, it will be replaced by number. So here it's a number and here it's a number. So it becomes an array of numbers. And in the same way here, I can pass a string. So t will be replaced with the strings. So that way we can customize the functionality of classes, not only functions using generics. Now let's move on to talk about another concept in generic, which is called generic constraints. It's a very interesting thing in generics. So let's define a class called dog, for example, and it has a method called print that console log I am a dog. Okay, and define another class called cat. Okay, and here I want to write I am a cat. And then I want to define a function called print animal. Okay, I want to pass here an argument arg. Okay, I want to annotate it with t. And of course I need to pass it as a generic, and then print, or probably return arg dot print. So the point I'm trying to convey is I want to pass an instance of either the cat class or the dog class. So I want to create instances of these and pass them to this function print animal. And I expect to get back I am a cat or I am a dog. So something like that. I want to const dog equals new dog, and that's it, yeah. Or a cat in another example. And then I can pass the print animal an argument of dog or cat. So this should work because dog has a method called print. If you can see, it has a print method, but TypeScript does not know that what I'm trying to pass to this function is an instance of cat or dog. So it makes sense that TypeScript is complaining because here I can pass anything like true, for example. And if I pass true, this boolean, of course, does not have the method print associated with it. So we need to tell TypeScript that this generic is not any generic. It's a generic that has this method. To do that, I define an interface. For example, I call it printable. And here I define a method called print. And it's a function that returns nothing, which is a void. And now I can say that this t, or this generic, extends the printable interface. And now you can see that there are no more errors from TypeScript in this case. Of course, it will complain here because true does not have the print, true does not extend the printable. So I need to remove that and write probably dog. So dog has print, that's why it accepts that. But now we can see that the print is working fine, but the problem is here I can pass anything like print double T or print name, okay? TypeScript has no idea that this name is wrong because there is a relationship between this class and this interface and this function or this generic specifically. To make things more specific and more typed, I can say that this dog or this class implements the printable interface. And this also implements the printable interface. And as soon as I say that this class implements imprintable, you can see that there is an error, class cat incorrectly implements interface printable. The reason is because the method is called print and here it's called print name. So I need to change that to print. Okay, and now it works fine. By the way, that's the importance, or that is the value of interfaces. They create a contract between classes. So if I want, when I say that this class prints printable, I make a contract with this class that it has to fulfill the requirements or the methods or properties defined in this interface. If it does not fulfill these requirements or these methods and properties, TypeScript will throw an error. So yeah, that's an off track, I know, but that's the point of interfaces. Now let's see a more complex and a harder example of generic constraints in classes. So I want to define a class called user and pass it a generic called t, and I want to define a constructor. In this constructor I want to pass a user as an argument, and it has the type t, and then I want to get value, and here I want to pass a key, and then return. Oh, okay, sorry, I forgot to initiate it public or maybe private. User return user key. So let's assume that the user I want to pass to this user class looks like this. Okay, it looks like this, an object of username, let's say it's Mark, and password, no, not password, age 26. Okay, and I can call the get value and pass it, for example, age, and I expect to get back 26. And if I pass something else like favorite color, I will get undefined. Okay, so let's analyze this code. First of all, we made an assumption that anything I want to pass to this user class is an object. Okay, I know that we can pass a string or anything to this t, I know, but let's assume that it is an object. I can write extra code to make sure that t is an object and cannot be anything else, but writing that extra code will make things more complex. So I want to avoid that because I want to convey a specific message about generic constraints. So anyway, assuming that t is an object, let's see the what we have here. We have a key, and this key is a string, and you can see I can pass any string, age, favorite color, username, name, country, whatever I want, and I get back a value, either a real value like number or string or whatever, or I get undefined because it doesn't exist. And in this case you might say that yeah, it's okay to do that, but I want to take full advantage of the type checking system of TypeScript, and I want to get here an error telling me that there is no value, or there is no key, sorry, there is no key called favorite color on this object that you have created recently. So how to do that? To do that, I use generics. So in this method, I can pass a generic. This generic is k. What is this k? K is the key of the object that I pass. Okay, this key or this key. But this k is not any generic. It's a generic that extends key of t. Okay, assuming that t is an object, k extends the key of t. So basically k is any of these. And also in key here, I want to pass it a type of k. And now you can see that I have an error saying argument of type favorite color is not assignable to parameter of type age or username. So unless I pass here a favorite color, red for example, unless I pass this in the object, I will continue to see errors. You see, there is an error. So to make things extra clear, I want to get back to my diagram, and I want you to understand something about generic and about strings. Is that first of all, the keys, okay, the keys of any object, this key or this key or this key, the keys of any object is a string. Even if I can pass a number like 5 or 45, or, for example. It doesn't make sense, but I can pass a number. But this number, when I want to access it, okay, like here, I can access it like this, okay? But behind the scenes, JavaScript or TypeScript converts this number to a string, because all keys, okay, all keys of objects inside JavaScript or TypeScript, all keys are strings. Even now it says no, it's a number, but you can try it in the console. Okay, you can try it in the console. You can see that all keys are strings in JavaScript. Keys of any object in JavaScript or TypeScript are strings. So in this case, okay, the key here, it was a string before we defined the key here, it was a string, right? And then we made a generic that we said, no, it's not any string, it's a specific string, and that is a key. So I want you to imagine that this generic, not only makes any more specific, it also makes these more specific, specifically strings. For example, in this case, a string is a general type, because anything can be a string. But in this case, I don't want any string to be the type of key. I want a specific string, and that is the key of objects. Okay, so we can imagine that there are bubbles or circles inside the string, and these bubbles or strings are more specific types of string. Okay, like in this case. In this case, K, or the key of the object, is a specific type of the string type. I know I'm talking like philosophy, but I'm trying to make things as clear as possible. So excuse me if there is extra gibberish in that, but that's basically it in TypeScript. And generic constraints and the advanced, some advanced syntax you can see in generic constraints. Now it's time to see an example of using generics in a real-life example in React.js, and how to manage state using generics. So I want to close this file for a while and go to this React app. By the way, this create React app is created. Okay, create React app. Okay, if you go to the documentation of create React app, you can see that you can add TypeScript, like in this case. Yeah, there is a template, this one or this one. I used this template to create this create React app, and I cleaned some of the extra files that come with the create React app, like CSS files or something like that. And I have now only the one component called app, and this component returns hi there. And if I run I already am running this React app. So if I go to localhost port 3000, I see hi there. So back to here. Let's suppose I want to talk to an API, to an external API, which is this API or this string, and returns an object or returns an array of objects, and print them here, like in a list, for example. And that's a very common thing to do in React.js and TypeScript. So let's go back to JSON placeholder. I want to show you something. This JSON placeholder is a fake API for testing, and it's free. And you can get users, you can get to-dos, photos, comments, whatever. I decided to get users because that's the easiest thing. And also, yeah, let's see how to define that. To define that, I want to write useEffect hook. Okay, useEffect. I want to clean some of the errors I get from my VS Code. So I want to write const fetch data equals async function. It's an async function that await get data. Probably I want to const users or fetched users equals to await get data. After I get the data, I want to log the fetched data. Sorry, fetched user. And then I want to, oh, sorry, what happened? I want to return. No, not return, sorry. I want to define a state, set users of fetched users. Okay, and then we can define a local state, useState hook, and define users, and then here set users. And here the users is an empty array. Okay, so we have some errors. The first error is what happened? Okay, the first error is get data. Get data is a function that doesn't exist, so we need to define it some way. Get data, I want to create a folder called utils, and inside this utils folder I want to create a file called getData.ts, and then I want to define export async function called getData and pass it a URL, which is a string. And here I want to get back a response from fetching or calling the fetch on the URL. This response is, by the way, is a promise, so I need to await for this promise to resolve. And then I want to return a response of response.json. Okay, like this. And what else? Now this function is done. Let's import that here. Okay, I want to pass it an argument. The argument is the URL of the API I want to go to, which is this URL. And now I want to call the function, which is fetch data, and get back to my console and see the data. Okay, you can see the data is being fetched from the API and being printed successfully. You can see the array of objects, and each object of user has ID, email, name, phone, etc. So it's working fine, but let me show you some errors that I might have in my code base right now. If I go to get data is a general function. It calls any API in the world, okay, like my own API, JSON placeholder, maybe Amazon URL, any API, and returns the response as JSON. So URL is 100% customizable because I can call this function with anything. But if I hover over this function, it says the return is promise any. Okay, I always recommend that you annotate your functions so you know what you are returning, and if there is something wrong, TypeScript will help you in detecting your errors. So in this case, I'm returning a promise, but I don't want to return any for reasons I already talked about. I want to return a promise with not any type. I want to return it with a generic type, which is more specific than any. It's still generic, but still more specific than any. So I want to return it with T. And now when I call this function, okay, when I call the function getData or invoke this function, I have to use a type inside as a generic. So let's see. Where is it? getData here. getData, when I call it, I have to pass a generic because at the moment it says the generic is unknown because I don't know what I'm trying to pass in here. because I can pass anything. So I want to be specific about what I want to pass inside this generic. And in this case, I want to pass a generic of type user. User is a type that doesn't exist yet. So in order to create a custom type in TypeScript, I can write an interface like this and pass it some properties and methods. In this case, let's see what kind of properties I have. Website username, yeah, let's define that. Username of string, and then I have phone as string. I have what else? Name, or maybe email, string. Okay, and now I tell TypeScript that getData should take a generic of user array. So the return, if I go back, the return of this function is a promise with an array of users. Okay, like this example of an array of users, and these users have these properties: username, phone, and email. And now I still have an error, but look, if I hover over fetch users, I know for sure that it will be returned as an array of users. And we have an error here. It says argument of type user array, argument of type user array is not assignable to parameter of type setStateAction never array. So what is this never array? Let's see here. If I hover over the useState hook, I see it accepts a generic of never array, like this. But what is never? Never in TypeScript is the opposite of any. So while any allows you to write anything, never doesn't allow you to write anything, because never is no type in TypeScript is assignable to type never. So it doesn't make sense to write never. But why the React documentations decided to write never? In this case, they decided to write never to enforce you to defend your code base against this bad keyword, which is never, because you don't want to use never in your useState because you want to return something. In this case, I want to be user array. So this array or this users is an array of users. Okay, that's why they used never, and we changed that to an interface called user. And the initial state is an empty array, and this empty array is not just any array, it's an array of users. Okay, and now we can use that safely here. If I want to use ul and pass users.map, then user, and return probably, let's say, li. li, and here I want to write user dot. As soon as I write dot, TypeScript automatically knows that I'm trying to access any of the properties inside the user interface. So let's try email. You can see the emails are being printed. If I tried something else like user.phone, yeah, I can see their phone numbers. So it's working just fine. So that's it for generics. You've learned how to use generics to write reusable code in functions and classes. You've learned generic constraints and pretty advanced syntax and generic constraints. And also I showed you some real life example of using generics in React.js to manage state and to call an external API. I doubt that there is any React application that doesn't call an external API and fetch some data from there and implement it inside the application. So I hope this video was helpful and useful for you. If it was helpful and useful, I would really appreciate it if you like this video and subscribe to my channel to support me and to support the YouTube algorithm. Write me some comments and give me some feedback. Until then, see you very soon.